Good evening, children.
Good evening.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening, children. Good evening. So in the last class, we understood the SAS congruence criterion. And then I think we also did ASA, right? We understood the SAS and ASA. Yeah, ASA congruence criterion. Now let's apply these criterion in proving that two given triangles are congruent to each other. Yeah, you've already watched the videos explaining these proofs. So you can volunteer to give the proof for this one. Example 1. So you can see the figure there wherein OA is equal to OB. Line segment OA is equal to the line segment OB. And the line segment OD is equal to the line segment OC. We need to show that the two triangles are congruent to each other. Triangle AOD and triangle BOC are congruent to each other. Now we understand this. To show that these two triangles are congruent, we need to consider these two triangles, triangle AOD and the other triangle BOC. We need to take up these two triangles, triangle BOC. We need to take up these two triangles and write three pairs of equalities. We need to write three pairs of equalities satisfying. So we know we have 5 congruence criteria. So satisfying any one of the 5 congruence criteria. For now, we know only 2. For now, we know only SAS and ASA. For now, we know only SAS and ASA. So maybe satisfying the SAS congruence criterion or the ASA congruence criterion. So we need to take up these two triangles which have to be proved are congruent. Write out 3 equalities. It can be a pair of equal angles or a pair of equal sides, but it should satisfy. If you want to use SAS, it should satisfy this one, or if you're using ASA, it should satisfy this one. The equalities which you write must satisfy the congruence rule. And again, what you write here should be of this triangle AOD equal to, so you will be saying equal to, and what you write here should be of this triangle BOC. So like, excuse me. So like if you write, so in the first triangle, let me just call this triangle 1 and triangle 2. So if you say OA of the first triangle is equal to which one of the second triangle? OA of the first triangle is equal to which side of the second triangle? OB of the second triangle, correct? So is that a valid equality? Valid equality meaning we are writing one side from the first triangle and the other side from the second triangle, and we are not saying they're equal. It's given that they're equal. If you write they're equal, you must justify why they're equal. If you are writing that by yourself, if it is not given, supposing OA is equal to OB is not given, but you are just writing that, then you need to give the reason as to why they are equal. So if you are writing OA is equal to OB when it is not given, but you are writing OA is equal to OB, then you must reason. Then you must give the reason as to why they are equal. Now here the reason, so for every equality must be supported by a reason. Every equality must be supported by a reason. So if it is given, given is the reason, given. If it is not given, you must justify why they are equal. So OA of the first triangle is equal to, now why are we taking these two triangles? Because we have to prove AOD, the first triangle, is congruent to BOC, the second triangle. So the side OA of the first triangle is equal to the side OB of the second triangle. Reason given. So we got S. Now we can use ASA or Okay, before that, let us see what all equalities we have. Let me not say S now for you. We'll just see what all equalities we have with us. All right. So we have this first one. OA is equal to OB. Okay, so that's about a side. Then we have OD of the first triangle is equal to OC of the second triangle. OD is equal to OC. Given. So we have another pair of equal sides. And see, we are not given that AD is parallel to BC. We are not given. So you cannot assume that. It's not given that AD is parallel to BC. Just because they look parallel, you cannot just say that they look parallel, so alternate angles are equal. All right, you cannot say that this angle is equal to this angle. Alternate angles are equal. See here. Parallel line, transversal, parallel line, supposing. Then alternate angles are equal. But here, no. Just because there's a Z form, children, don't say alternate angles are equal. Because you don't know if the lines are parallel. So you cannot use alternate angles here or corresponding angles. You cannot use that because you don't have parallel lines. You have two lines intersected by a transversal. Am I audible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right.
Yes, ma'am.
Yeah, children, thank you. So we have two lines intersected by two transversals actually. See, we have like this. We have one like this, line, transversal, line. This one. Line, transversal. Oh, sorry. Transversal, line. Oh, we also have, excuse me. We also have line, transversal, line like this. We have two lines intersected by two different transversals, but no alternate angles, corresponding angles here, because you cannot say they're equal because the lines are not parallel. They're not given to be parallel. So now, as of now, we have identified two pairs of equal sides. Angles, we don't know. We can't say that this angle is equal to this angle because lines are not parallel. We don't know if the lines are parallel. So you can't say alternate angles are equal. They are alternate angles, but you cannot say that they are equal because you don't know if the lines are parallel. So now what do you say about angle 1 and angle 2? What do you say about angle 1 and angle 2?
Are equal, ma'am.
What kind of angle?
They're equal.
Vertically opposite.
Vertically
Angle 1 is
opposite
equal
angle.
to angle 2. Yeah,
Vertically opposite angle.
yeah, vertically opposite angles are equal. Okay, vertically opposite angles are equal everywhere. Vertically opposite angles are equal. When you have two intersecting lines, the vertically opposite angles formed are equal. This angle is equal to this angle, and this angle is equal to this angle. Vertically opposite angles are equal. So now what kind of equalities we have? We have one pair of equal sides, another pair of equal sides, and one pair of equal angles. Now, when you have two pairs of equal sides, yeah, when you have two pairs of equal sides and one pair of equal angle, then you only have this. It should satisfy SAS. It should satisfy SAS. For SAS, it should be two sides and included angle. So you can see here in the first triangle we mentioned about OA, we mentioned about OD, and you can see angle 1 is clearly the included angle in this triangle. In the second triangle we mentioned about OB and OC, and you can see that angle 2 is clearly the included angle in the second triangle. I told you what is meant by included angle. The arms of the angle must be the sides you have mentioned in the proof. See here, the arms of the angle 1, arms are OA and OD. Yes, we have mentioned about OA and OD in the equalities. And for angle 2, the arms are OB and OC. And here also we have mentioned about the arms OB and OC in the proof. So clearly two sides included angle. So by SAS congruence criterion, the two triangles are congruent to each other. Excuse me. So by SAS rule, the two triangles are congruent to each other. Go through the proof here. Please see the proof here, children. It's here.
Yes, ma'am.
Yeah. Essays congruence criterion. All right. So now let's understand the second part. So this is, we just finished this. So the two triangles are congruent to each other. They're identical. The two triangles are identical. They're congruent to each other by Essays congruence criterion. Okay. Now that they're, and I told you, how do you name the triangles? How do you name the triangles? That order is important. See here, we have mentioned about OA. Just look at these equalities. We have mentioned OA. We have mentioned OA is equal to OB. Look at this one. OA is equal to OB. And here OD is equal to OC. We have mentioned about OA and OB. OA is equal to OB and OD is equal to OC. Just take up these two and write it like this. AO. Just write it in a different way. See here, you will see how to name the triangles. So let's say AO. AO is equal to BO. AO is equal to BO and OD is equal to OC. Okay, see, I have written this one. OA is equal to OB as AO is equal to BO. Okay, and then this one, OD is equal to OC. OD is equal to OC. What I'm saying is, in these two equalities, this vertex O is common. In these two equalities, the vertex O is common. See, the vertex O is common. So let us write it like this. AO, O is OD. That is, let's end the first one with the common vertex. Let's begin the second one with the common vertex. See here, AO, OD. So it is triangle AOD. Here, BO, OC. We end with O, we start with O. BOOC. So it's like BOOC. BOC. So this is the order. Triangle AOD is congruent to triangle BOC. That's what you see here. Triangle AOD is congruent to triangle BOC by the SAS congruence criterion. So now that the triangles are congruent, their remaining parts, corresponding parts are also, we know that there are 6 pairs of equalities. When you take up two congruent triangles, there'll be 6 pairs of equalities, 3 pairs of equal angles, 3 pairs of equal sides. Now we already know 3. We know 1 pair of equal angles. The remaining 2 pairs of corresponding angles are equal now. We know 2 pairs of equal sides. That third pair is also equal now. When two triangles are identical, when two triangles are congruent, their corresponding sides and corresponding angles are equal. We'll have 3 pairs of equal angles and 3 pairs of equal sides, of which we already know 3 equalities. So the remaining 3 you can use this one, use this order and find out. Let's understand more clearly. So now this order, I hope we understood. Now the vertex A corresponds to the vertex B, which is vertex A of AOD. This one corresponds to the vertex B. This is understood, children?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
All right. Then vertex O. The vertex O corresponds to the vertex O. See here, O corresponds to O. Yeah, correct. No, O and O, they're equal. This angle at O is equal to this angle at O. Yeah, that we already know. Then D corresponds to C, which is D. This is D. D of the first triangle corresponds to C of the second triangle. That means if I number this 1 and 2, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. Why are they equal? Because they're the corresponding vertices. They're the corresponding angles. A corresponds to D. A vertex A corresponds to vertex B. Vertex A of the first triangle corresponds to the vertex B of the second triangle. That means angle A is equal to angle B, or angle 1 is equal to angle 2. Similarly, you can see D corresponds to C. The third vertex here, D, corresponds to C. D corresponds to C. That means now that the triangles are congruent, angle 1 is equal to angle 2, angle 3 is equal to angle 4. Reason? Corresponding parts of congruent triangles are congruent. CP-CTC. CP-CTC. All right. So now 1 is equal to 3. And which is the other pair of equal sides, children? We know 2 pairs of equal sides. Which is that other pair which is equal now? Yes.
Oh,
Ma'am, I can't understand the question. Could you please repeat it again?
Yeah, sure. No. Which is the third pair? In the question, we already have 2 pairs of equal sides. Now that the triangles are congruent, which is the third pair of sides that are equal?
Ma'am, AD and BC, ma'am.
AD is equal to BC. AD is equal to BC. AD, this one, AD is equal to BC. Okay, so now that the triangles are congruent to each other, by SAS, we need to, the next part is to prove that AD is parallel to BC. So now CP-CTC, this angle OAD is equal to this angle OBC. See, OAD is equal to OBC. Why? Because the triangles are congruent. So their corresponding vertices are equal. Their corresponding angles are equal. So angle A is equal to angle B, CP-CTC. Children, now that the triangles are congruent, you can relate the vertices. Vertex A corresponds to vertex B. Vertex A corresponds to vertex B. A corresponds to B. A can also be written as angle OAD and B as OBC. Angle OAD is equal to OBC. What is the reason? Angle OAB is equal to angle OAD equals OBC. Reason?
Ma'am, because they are opposite angles, ma'am.
No.
ma'am, can you repeat? Ma'am, actually network is little for me.
What's the reason? What's the reason? Why is angle OAD equal to angle OBC?
Ma'am, by CP-CT, ma'am, corresponding parts of congruent
Ma'am,
triangles.
they are alternate interior angles, ma'am.
No. Do you know that the lines are parallel? Who was that alternate angles?
After knowing, ma'am, I told.
No, we haven't still come there. No, as of now, we only know that the triangles are congruent. Now, what do we know?
Okay.
Now we only know that the triangles are congruent. So when you say in these two triangles, when you say that 2 angles are equal, that is one angle of the first triangle is equal to one angle of the second triangle, the reason will be CP-CTC. Corresponding parts of congruent triangles are congruent. After showing that the triangles are congruent, if you say that one side of the first triangle is equal to one side of the second triangle, the reason is CP-CTC. Corresponding parts of congruent triangles are congruent because we took the corresponding parts only. No, see here, after writing this, see here, angle A, the first vertex here, corresponds to angle B. angle A or the vertex A corresponds to vertex B. That's what is corresponding parts, corresponding angles of these two congruent triangles are congruent, meaning equal. So now tell me what's the reason for angle A is equal to angle B?
CPCT.
I'm CPCT, ma'am.
Yeah, CPCT or CPCT-C. Corresponding parts of congruent triangles are congruent. Anything?
Yes, ma'am.
Okay, can I say angle D is equal to angle C? Can I say angle D is equal to C?
Yes,
Yes,
ma'am.
ma'am.
Does the vertex D correspond to vertex C?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So if we can also say angle D. So you take any one of the two, right? Any one of the two. So angle OAD. Excuse me. These two angles are equal, CPCTC. These two angles are equal, CPCTC. Oh, they're equal angles. So see here, angle A is equal to angle B. But they form a pair of alternate interior angles. If these two angles are equal, these two are alternate angles by their positions, whether the lines are parallel or not, whether the lines are parallel or not, by their position, they are alternate angles. But now they are equal. That means the lines must be parallel to each other. That means the lines are parallel to each other. So you must say, but angle OAD and angle OBC, they are alternate angles. They are made by the lines BC and AD. They are made by this transversal. They are made by this transversal AB with the lines BC and AD. And they're equal. Those two angles are equal. That means these two lines must be parallel to each other. You know that when lines are parallel, alternate angles are equal. Conversely, when the alternate angles are equal, that means the lines must be parallel to each other. When a pair of alternate interior angles are equal, when a pair of alternate interior angles are equal, that means the lines are parallel to each other. When lines are parallel, alternate interior angles equal. So here it's a converse. Alternate interior angles are equal. So the lines must be parallel to each other. And that's how we have AD parallel to BC. AD is parallel to BC. See, this angle is equal to this angle. How are these two angles formed? They are formed. See here, how are these two angles formed? They are formed like this. They are formed here and here because of these two lines. These are the arms of the angle. These are the arms of the angles. So they are formed. These angles are formed by the transversal AB. Can you see the transversal AB? This is the transversal AB. These two angles are a result of this transversal AB with intersecting the lines BC and AD. As a result, these angles are formed. These angles are formed as a result of this transversal meeting these two lines. These alternate angles are equal. These two alternate angles are equal because the triangles are congruent. CPCTC, they are equal. Alternate angles are equal. That means the two lines must be parallel to each other. A pair of alternate interior angles are equal. So the lines must be parallel to each other and hence AD is parallel to BC. So this is how we say. These angles are equal not because they're alternate angles, CPCTC, but they're alternate angles. These two angles are equal because the triangles are congruent, CPCTC, but they're alternate angles. By the position, they are alternate angles made by this transversal AB where the lines AD and BC and the alternate angles are equal. Then the lines must be parallel to each other. So AD is parallel to BC. Is it clear, children?
Yes, ma'am.
Yes,
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right. Take a screenshot. I've just missed to write these two here. I missed to type the rule. You must always mention the rule. I've forgotten to do that here. Essays. Take a screenshot with this. And here you must mention CPCTC. I forgot to do that. Please practice the proof. Now an example 2. AB is a line segment. Okay. And line L is its perpendicular bisector. Perpendicular bisector. Perpendicular meaning it makes 90 degrees. Bisector meaning C is the midpoint of AB. Because this line L is not only, this line L not only makes a right angle with AB, it's perpendicular. It not only makes a right angle with AB, but it also bisects AB. See here, AB is a line segment. And L is its meaning AB is perpendicular bisector. Its meaning AB is perpendicular bisector. L is, this line L is AB's perpendicular bisector. Perpendicular. So L makes 90 degrees with AB. Bisector, that means C is the midpoint of AB. Because where does L meet AB? L meets AB at C. And because it bisects L, okay, let me tell you like this. L is perpendicular to AB. There are two things there. L is perpendicular to AB. And L bisects AB. So L bisects AB. There are two things there. Perpendicular bisector. L is perpendicular to AB. L bisects AB. If L is perpendicular to AB, that means L makes 90 degrees with AB. L bisects AB means L divides AB into two equal halves. Where does L meet AB? At C. L meets AB, the point of intersection. L and AB, they intersect at C. The line L and the line segment AB intersect at C. So that means C is the midpoint because L bisects AB. It cuts AB into two equal halves. So AC is equal to BC. So these things are given in words. This is what we have to understand. Arav, what's the measure of angle ACP?
Ma'am, 1 minute, ma'am.
Yeah. What is the measure of angle ACP?
Ma'am, 90 degree, ma'am.
90 degrees. ACP is equal to 90 degrees. Which other angle is 90 degrees?
Ma'am, PCB, ma'am. CB, ma'am.
PCB is also 90. Okay.
Yes, ma'am.
Now, if I say AC is equal to, okay, if I say AB is equal to 2 times AC, am I right? AB.
Yes, ma'am.
Okay, if AC is 5 centimeters, how much is BC?
Ma'am, 5, ma'am.
Why?
Ma'am, because you told that BC is equal to 2 AC, ma'am. So if that is 5, this will also be 5, ma'am.
Yeah, but how do we know that C is the midpoint of AB? What is meant by L bisects AB?
Ma'am, it goes in the midpoint of A and B, ma'am.
Correct, AB. And what is meant by L is the perpendicular? L is perpendicular to AB.
Ma'am, it is on the line AB, ma'am.
No, perpendicular gives you what information? L is perpendicular to AB.
Yes, ma'am.
Yeah, what information does that convey?
Ma'am,
Okay, no problem. You understand, answered most of it. Yes, somebody tell me. L perpendicular to AB conveys what information?
Ma'am, that BCP is 90 degree. Ma'am.
Yeah, that BCP, L perpendicular to AB means BCP is 90 degrees. See, this is L. Let's all see where L is. This is L. This is L. If you did not notice it, this is L. It's marked there. Did we notice that? This is L. L.
Yes, ma'am.
Yeah, this is
Yes,
L.
ma'am.
This line L, it's a line. You can see arrows at its either ends. This is a line. And there is the line segment AB. Okay. So there is a line like this, and there is a line segment AB. This L is perpendicular to AB, means it makes 90 degrees with AB. This is where it meets. L meets AB here at C. This is A, this is B, and this is that line L. L is perpendicular, meaning L makes 90 degrees with AB. And L bisects AB. See, AB is this length. It's cut into two equal halves. So C is the midpoint. Why C should be the midpoint? Because L meets AB at C. This line L meets AB at C. So C is the midpoint of AB because bisects. If they say only perpendicular, L is perpendicular to AB, that means only 90 degrees. If they say L bisects AB, only that midpoint, C is the midpoint of AB. But here L is the perpendicular bisector, both perpendicular bisector of AB. So 90 degrees as well as the midpoint. Okay. Now P lies on L. P, this point P lies on the line L. Yeah, we can see that. Show that P is equidistant from A and B. So it's like this is your house. Okay. This is your house and this is your friend A's house and this is your friend B's house. And if you're telling somebody in your family that, you know, our house is equidistant from A and B's house. This is your house. This is your friend's house. This is another friend's house. And you're telling your family member that, you know, your house or our house is equidistant from A's house and B's house. That means the distance is the same. Supposing this is 10 kilometers. Supposing the distance between your house and your friend A's house is 10 kilometers. The distance between your house and this friend B's house is also 10 kilometers. Equidistant, equal distance. The distance between P and A is equal to the distance between P and B. Equidistant, equal distances. P is equidistant from A and B. What is, who can tell me the distance of P from A? No, not the numerical value. Just try to answer this. Let me see what kind of answer you can give me. What is the distance of P from A?
10 kilometers.
No,
A
no,
was the distance from B to A.
no, no,
From
no.
B to P.
No, I'm sure my question is not very specific. I'm just trying to see how well you can answer this. Or shall I put it like this? What represents the distance between P and A?
Ma'am, the distance between P and A is equidistant to P and B, ma'am.
No, no. What here in the figure represents the distance between P and A? P is a point. A is a point. The
Ma'am, the
distance.
perpendicular bisector, ma'am. See.
No, no. What represents the distance between these 2 points, P and A? This is a point X. Okay. This is a point Y. Now, to find the distance between X and Y, what will you do? What will you do to find the distance between X and Y? Now, okay, we'll assume that you can measure the distance using a scale. Okay. Now you have on your book, you have you've marked a point X like this and another point Y like this. And using the scale, you'll have to find the distance between these 2 points. What will you do first?
Ma'am, what ma'am? I can't understand.
Oh, that's all. Whatever you understood from what I said. How will we find the distance between these 2 points? What represents the distance between the 2 points X and Y?
Ma'am,
The points, ma'am.
Ma'am,
point.
starting and the ending point, ma'am.
The point.
No, I heard the answer from somebody. Yeah.
The starting.
And the starting
Ma'am,
and
a
the
line.
ending.
Starting and the ending point.
Yeah. So you want me to connect these 2, right?
Yes, ma'am.
Yeah. So
Yes,
now
ma'am.
yes. The
Distance between the two.
it's a line segment XY, right?
Yes, ma'am.
Yeah, the line segment XY represents the distance between the points X and Y. The line segment XY. The line segment XY represents the distance between the points X and Y. Similarly, here the distance between the points P and A. Somebody's mic is enabled. Please disable your mic. So here the distance between the points P and A is represented by
Line segment.
line segment
AP.
AP, line segment AP. The line segment AP represents the distance between the points A and P. Now look at this point P and B. Point P, point B. The line segment PB is the distance between the points P and B. So when we say P is equidistant from A and B, so your question is, what is the distance of P from A? What is the distance of P from A? The line segment PA is the distance of P from A. What is the distance of P from B? Sorry, from B. So this line segment PB, that line segment connecting the 2 points. It's given that these 2 are equidistant. That means these distances are the same. The distance PA is equal to the distance PB. This is given to us. I'm sorry, this is what we'll have to prove. Sorry, this is what we have to prove. We need to prove that PA is equal to PB. So we're given this information. L is perpendicular to AB. L bisects AB. We need to show that PA is equal to PB. PA is equal to PB. So now how should you understand? How do we go about this? To prove that PA is equal to PB, we know that PA is a side of this triangle and PB is a side of this triangle. PA is a side of triangle 1 and PB is a side of triangle 2. So what should occur to you is, if you show that these 2 triangles are congruent to each other, if you can show that triangle 1 and triangle 2 are congruent to each other, then maybe CPCTC, corresponding sides will be equal. So that way you can get PA is equal to PB. This is why we show that the triangles are congruent. We show that 2 triangles are congruent to each other because of the results that follow. When the triangles are congruent, they're matching, their corresponding angles will be equal and their corresponding sides also will be equal. So here you have to show that PA is equal to PB. PA is of triangle 1, PB is of triangle 2. PB is of triangle 2. PA is of triangle 1, PB is of triangle 2. So if we prove that these two triangles are congruent to each other, then we have the results that follow. Corresponding parts are congruent, are equal. So that way, if PA and PB are the matching parts, they'll be equal. So, and you can prove that P is equidistant from A and B. That is why we'll have to show that these two triangles are congruent to each other. So let's take up the two triangles, 1 and 2. We know that this is 90 degrees, this is 90 degrees, and this one AC is equal to BC. We know that. Okay, so let's begin. And we know that this is the common side. PC is a side common to both the triangles. PC is a side common to both the triangles. So in triangle APC, and triangle BPC, in the two triangles, list out the equalities you have. AC of the first triangle is equal to BC of the second triangle. See, when you're writing these equalities, the side or the angle should be complete sides or complete angles of the first triangle. And that should be equal to a complete angle or a complete side of the second triangle. See, you can see that AC is one side of triangle 1. BC is one side of triangle 2. So AC is equal to BC is a valid information. AC is equal to BC. Then this angle you can call it angle ACP is equal to angle BCP. ACP is of the first triangle, is an angle of the first triangle. BCP is an angle of the second triangle, 90 degrees. ACP is equal to BCP, 90 degrees. Given. And then CP is a side common to both the triangles. CP is equal to CP. So we have listed one pair of equal sides, one pair of equal angles, another pair of equal sides. And you can see that this angle is contained by the two sides. This angle is contained by these two sides we have mentioned. And the other angle also is contained by these two sides. This angle is contained by these two sides. So clearly SAS rule the triangles are congruent to each other. And CP/CTC, you would get this result, PA is equal to PB. Let me just show you the proof. So I'll tell you how to name the triangles in order. So now see here, AC, BC. AC, C is the, take up this one. Take up this one. AC is equal to BC and PC is equal to PC. Which is the common letter, children? AC, PC, which is the common letter?
C, ma'am.
C, ma'am.
Right? AC, CP. You can just do this in your mind. You don't have to write it anywhere. You can just do this in your mind. And BC, CP, correct? C is the common letter. AC, CP. See, this information, we're just rewriting this. AC, BC, you can just write it as it is. We write PC as CP, PC as CP, CP is equal to CP. CP is equal to CP. So ACP, BCP. ACP, BCP, ACP, BCP. So once the triangles are congruent, then you can see the corresponding sides AP, CF is equal to BP. CP/CTC. If AP is equal to BP, that means P is equidistant from A and B. Please go through and see if you have any doubts. Please read what is given, what is to be proved, and then the proof. The three equalities we have mentioned satisfies the SAS congruence rule. Is the process understood, children?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Yes, ma'am.
All your children. How do you do this? Line segment AB is parallel. So AB is parallel to CD. O is the midpoint of AD. Please mind that. O is the midpoint only of AD. That means AO is equal to OD. I want somebody to say the proof.
Ma'am, am I audible?
Yes.
The answer, ma'am.
Yeah, tell me the proof. Yes.
Yes,
Tell me the triangles we need to consider first.
triangle AOB and triangle DOC.
Okay. For now, the way we name the triangles is not important.
Okay.
Oh, yeah. Yeah.
Angle AOB is equal to angle DOC.
Sangam, just give me a minute. 1 minute. 1 minute. Yeah, Sangamitra, please continue. Sangamitra?
Yes, ma'am.
Yeah.
Angle AOB is equal to angle DOC since they are vertically opposite angles.
Okay. So we'll say 1 is equal to angle 2, right?
Yes.
Okay. Angle 1 is equal to angle 1 of triangle AOB is equal to angle 2 of triangle DOC. Yeah, correct. Next.
Since O is the midpoint of AD, OA is equal to DO.
OA is of which triangle?
OA of a triangle AOD.
AOB.
Yes, AOB.
Okay. So OA of triangle AOB is equal to
OD of triangle DOC.
Okay. Yeah, correct.
Now, since AB is parallel to CD, angle OAB of triangle AOB is equal to angle ODC of triangle DOC.
Oh, very good. Okay. Angle 3 of the first triangle is equal to angle 4 of the second triangle. What's the reason?
Your vertically opposite angles, ma'am. AB is parallel to CD. It's given in the question.
Vertically opposite angles?
Sorry, ma'am.
Alternate interior angles. Because these lines are parallel. These lines are parallel. These two angles, 3 and 4, they form a pair of they form a pair of alternate interior angles and they're equal. Yeah, because the lines are parallel. So now we have mentioned 2 pairs of equal angles and 1 pair of equal sides. 1 pair of equal sides. So now we need to check if this side. So what rule does this make, Sangamitra?
ASA criteria.
Yeah, ASA. This makes ASA. But the ASA means 2 angles and included side. An included side. Let's check. Let's check if it's included side. So we have mentioned about this angle and this angle. And then we mentioned about this angle and this angle. Okay. In the proof, we have mentioned about angle 1 and angle 2. And then we mentioned about angle 3 and angle 4. Now, this angle 1 and angle 3, include the side OA. See, this is the triangle. This is the triangle. This is the triangle. When you say angle O, this angle 1 and angle 3, it includes the side, or they include the side OA. Angle 2 and angle 4 include the side OD. Include the side OD. The side include. See, there is the angle included by 2 sides, and there is a side included by 2 angles. So here for angle 2 and angle 4, angle 2, angle 4, OD is the included side. OD is the included side. OD is the included side. And yes, we have mentioned about OA and OD. OA is equal to OD. We have mentioned. We have listed 3 equalities. That pair of equal sides are OA and OD. OA is equal to OD. Included sides equal. So ASA congruence criterion, the 2 triangles are congruent to each other. Very easy to name the triangles. So now you know that angle 1. If you call this triangle AOB, if you call this triangle AOB, the first triangle, if you name it AOB, AOB, you know that this angle corresponds to this angle. So you must start with D for the second triangle. D. If you call this triangle AOB, match the vertices. A goes with this vertex D, because these 2 angles are equal, alternate angles. So D. Then for O here, if you say O in the first triangle, you must say O in the second triangle, because vertically opposite angles. No, O in the second triangle. And automatically the third vertex C. So if you say AOB, you must not write COD. That's wrong. If you have cardboard cutouts of these 2 triangles, you must place the vertex A over vertex D, vertex O over vertex O, and vertex B over vertex C. Only then they'll coincide. Otherwise, they'll not coincide. They are congruent, but you have not placed them correctly. You have not matched the vertices, so they might not coincide, though they are congruent, because you have not placed them correctly. You must see that vertex A coincides with vertex D, because they are the angles which are equal. Angle A is equal to angle D. And you also know that angle B is equal to angle C, alternate angles. So when there is B, there should be C, third positions. So the triangles are congruent to each other by the ASA congruence criterion. Now we need to prove that O is also the midpoint of BC. We did not know. We are not given that O is the midpoint of BC. But now that the triangles are congruent, you can see here OB. You can see the side OB that matches with OC. OB matches with OC. See here, OB matches with OC. So that means OB is equal to OC. OB is equal to OC. CPCTC. OB is equal to OC. OB of the first triangle is equal to OC of the second triangle. CPCTC. What do we mean by that? OB is equal to OC. OC is this one. OB is this one. That means O is the midpoint. That means O is the midpoint of BC. O is the midpoint of BC. Please read. Any questions, children?
No, ma'am.
No, ma'am.
All right. I hope you're all taking screenshots.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. Yeah. Yes, we can do this one. In quadrilateral ACBD, AC is equal to BC. I'm sorry, AC is equal to AD. Okay, that's marked. And AB bisects angle A. AB bisects the angle. No midpoint and all that here. AB, this line segment AB, it bisects this angle. That means these two portions are equal. These two portions are equal. Angle 1 is equal to angle 2. Because there is an angle like this. There is an angle like this. There's an angle like this. And there's a line segment AB like this. See, this is the angle. So there's an angle like this. So this is the complete angle. Say it's 80 degrees. Say it's 80 degrees. Now this line, this is the vertex A, right? So now this line segment AB, it runs through A like this, AB. And it's given that AB, if AB bisects this angle, that means this angle is cut or divided into two equal halves. So this will become 40 here and 40 here. Bisects, meaning the angle is divided into two equal angles. So here you can say angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Because AB bisects angle A. Angle A is the full angle A. When they say A, it means whole of angle A. The whole angle A. This is the whole angle A. It's divided into two angles, 1 and 2. Two equal angles, 1 and 2. So show that triangle ABC. Show that this triangle ABC, this one, is congruent to ABD, this one. Yes, I want Tarun to say this. Tarun, are you there? Class, use the emoji. Raise your hand. Shivani, Shreyas, Hitesh, Pratiksha, Kanishka, Sangamitra, Vasudevan, Ananya, Arav, Nivedita, Tarun, Pranav, Nikita. So I can see Tarun in the meeting. Tarun, please unmute yourself and share your thoughts on this one. Vasudevan, can you try?
Ma'am, can I
1 minute.
try?
Kanishka. Who else can? Kanishka says then.
Ma'am, can I?
Shreyas, okay. Kanishka, Shreyas. Who else? That's all. Tarun, please share something in the chat box. Why is it that you're not able to unmute and talk? Is your mic out of order? Ananya also.
Voice is here.
Yes, children?
Ma'am, now your voice is clear. Before it
Now
was
it's
little
clear,
blur,
ma'am.
ma'am.
Before it was tracking, ma'am.
Yeah, no. I think when she unmuted, there was noise from the background. Okay. I don't know. Okay, fine, Ananya. All right. Okay, let me ask Kanishka. Tell me, Kanishka.
Ma'am, angle 1 is equal to angle 2, ma'am.
Okay.
As AB bisects, ma'am. Angle
Tell me
A.
like this. 1 minute. Please tell me like angle 1 of triangle ABC is equal to
Okay, ma'am.
angle 2 of triangle ABD. Yeah.
Okay, ma'am. Angle 1 of triangle ABC is equal to angle 2 of triangle ABD, ma'am.
Okay.
As AB bisects angle A, it is divided into 2 equals, ma'am.
Yeah, correct. Next.
And AD is parallel to AC, ma'am.
Excuse me. AD is?
Parallel to, sorry, ma'am, equal to AC, ma'am.
Yeah, AD is equal to AC. Yeah. I told you something, no? AC of triangle.
Sorry, ma'am. AC of triangle ABC is equal to AD of triangle ABD.
Okay,
Is
enough. Thank
equal.
you. Okay, thank you. Shreyas, continue.
Ma'am, BC of triangle ABC is equal to BD of triangle ABD, ma'am.
What's the reason?
Ma'am, because AB is the bisector, ma'am.
Kanishka, do you agree with him?
Ma'am,
He says,
just a second.
he says BC is equal to BD. Yeah, class. Shreyas says BC is equal to BD. Is he right?
Ma'am, I think I don't think the reason is maybe right.
Yeah, the reason you think is not right. Okay, because what is conveyed by AB bisects angle A? Only one thing is conveyed. That angle 1 is equal to angle 2. Nothing else. Our imaginations are not conveyed. Only this one, angle 1 is equal to angle 2. That's all is meant by AB bisects angle A.
Ma'am, can I say the last one also?
Okay, so children, BC is equal to B. See now, when Kanishka said angle 1 is equal to angle 2, we have a reason. AB bisects angle A. And she said AC is equal to AD. Yeah, that's given. But when Shreyas
I
said,
have another reason, ma'am. I don't know whether it is correct or wrong, ma'am.
What's that?
No, ma'am, the last one. That is AB is equal to AB common side.
Yeah, that's what it is. AB is equal to AB common side. So what rule does it make?
It says.
SAS, ma'am.
SAS. Because have we spoken about in the first triangle? In this triangle, have we spoken about AC?
Yes, ma'am.
Have we spoken about AB?
Yes,
See, when
ma'am.
we spoken about, have we written those three equalities, Have we written about AC? Yes. Have we written about AB? Yes. Have we written about this angle?
Yes, ma'am.
Yes. So see here, two sides include angle. You can see it here, two sides include angle. In the second triangle also, see here, we have mentioned about this side, the second triangle. We have mentioned about this side in the second triangle, and we have mentioned about this angle. So again, SAS, two sides include angle. So the two triangles are congruent to each other by SA's congruence criterion. What can you say about BC and BD? You can see it there. I hope you're reading through the proof. Niveda, are you there?
Yes, ma'am.
Following Niveda?
Ma'am, what, ma'am?
No, are you following the class?
Yes, ma'am.
Have you watched the recordings which I shared earlier with you?
Yes, ma'am. You sent 2 videos, ma'am. I watched that, ma'am.
Okay, there I have explained congruency, right? I think
Yes,
you took. Okay, so you understood the introduction to the chapter. I think that's what I shared with you, right?
Yes, ma'am. You shared the introduction of this lesson, ma'am. I watched, ma'am.
All right, good. Okay.
Yes, ma'am.
So what can you say about BC and BD?
Ma'am,
Equal.
they are equal by corresponding parts of congruent triangles, ma'am.
Okay. And see how do you name the order? See here, which is the common letter? A, B, A, C. What's common?
A, ma'am.
Let's write this B and AC. What should I write here is equal to? BA is equal to? What should I write here?
BAC, ma'am.
Then here? What should I write here?
CA, ma'am.
C. CA, ma'am.
No.
AD, ma'am.
Who said AD?
Pratiksha.
Pratiksha says AD. Okay. Why AD and not DA, Pratiksha? Excuse me. Why should it be AD and not DA?
Can I tell, ma'am?
Yes, Pratiksha.
Ma'am, I'm Nivedita, ma'am.
Yes, Niveda. Oh, Nivedita, is it? Okay, Nivedita. Yes.
Ma'am, because A is the common point, ma'am.
Yeah.
Which
Okay.
divides two triangles, ma'am.
So when you say no, but how have you understood this? What is that we are doing here? Why are we writing this?
Ma'am, to prove that the BA is equal to BA, that is the bisector, and AC is equal to AD, ma'am.
No, correct. But why we've already mentioned that, right? Why are we trying to write this again? And what are we trying to do with this? Yes, somebody tell me why we trying to rearrange the vertices like this?
Ma'am, to form the correct triangle BAD and BAC.
Who was that?
Nivedita, ma'am.
Yeah. To name the triangles in the correct order, to get the names correctly, to name the triangles in the correct order. Okay, so this first equality, AB is equal to AB. We write it as BA is equal to BA. AB we write as BA.
Ma'am, I have a doubt, ma'am.
Yeah, and let me just finish this. Then here we have AC is equal to AD. We write AC is equal to AD as it is. See, the A is the common letter, children. A is the common letter. BAAC. And here also BAAD. So it's going to be BAC, BAD. So see here, triangle BAC is congruent to triangle, BAD. BAD. So that also means now here we have ABC and ABD. That's because we have just copied from here. ABC congruent, because we had to prove no ABC congruent to ABD. So simply we just write ABC ABD because we had to write that ABC congruent to ABD. So we wrote ABC congruent to ABD. This also is the correct order. This also is the correct order. BAC congruent to BAD. So from this, see here, ABC congruent to ABD. Can you get it? See the second, write the second one first. ABC. Second vertex, then the first and then the third. ABC, ABD. Just a minute, children. Okay, so this order BAC congruent to BAD is the same as ABC congruent to ABD. That why have we written ABC ABD here? Because that's what is asked here. We have to prove that ABC is congruent to ABD, so we just go with that. See, normally children we just write whatever is given here, but you can check it. You can check if it is right. You can write your order, what you understand, and with that you can check this one. So this is our order, BAC, BAD. So you can see here ABC, ABD. Now what can you say about, now that the triangles are congruent, what can you say about BC and BD? So BC and BD, CPCTC. They are the corresponding parts of congruent triangles, so they are equal. What can we say about BC and BD? BC and BD are equal. BC is equal to BD, CPCTC. Fine, children?
Yes, ma'am.
All right. Okay. So here we have to first prove that ABD is congruent to BAC. So I've just taken up the two triangles separately because these two triangles are found in the quadrilateral. These two triangles are found in the quadrilateral. So we'll take them separately like this. ABD, ABD. See here, I've just taken up the triangle separately here, ABD, and the other, see this triangle ABD and BAC. ABD and BAC. If I zoom in, I cannot write, which is why I zoom out. So ABD, you can see triangle ABD here and triangle BAC here. And I marked the equalities given. It's given that AD is equal to BC. So I marked that. And it's also given that angle DAB. See, this is angle DAB. I marked angle DAB is equal to CBA. So I marked that. So easy. Now we'll have to prove that these two triangles, and you can see that AB is already equal. AB, same side. AB, same side. So what is the congruence rule? Everything is given. See here. We have three pairs of equalities in these two triangles. Am I audible, children?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All right, children. Yeah. See, when you take up the two triangles separately, you can see that, you know, you can see the three pairs of equalities. Two pairs of equal sides, one pair of equal angles. And you can see angle in both the cases is the included angle. Yeah, so go through the working. Somebody's mic is enabled. Kindly disable your mic. See, all this we must write. The answer starts from here. This is the question. It ends here. You must write what is given, what is to be proved, and then you must start the proof. what is given. You must write that in short. Don't write the question fully like that. Just try to make it as short as possible, conveying the information given, under given, and whatever is to be proved, to prove. And then the proof. And if at all you're marking the angles, you must draw the figure again and mark the angles. Please go through the answer. Please go through the proof. So you mentioned two triangles. You mentioned two triangles. These two triangles we'll have to prove are congruent. So you must write all this from the first triangle equal to all this from the second triangle. And in the bracket, you must give the reason given or common side or whatever alternate angles, vertically opposite angles. You must justify every equality. Done, children?
Yes, ma'am.
All right.
Yes, ma'am.
So since we'll have to show that these two triangles are congruent, take up the two triangles. So AD of the first triangle, AD of the first triangle is equal to BC of the second triangle given. And I've marked the angle. So I've marked this as angle 1 and this one as angle 2. So angle 1 of the first triangle is equal to angle 2 of the second triangle. See, when you're looking at the first triangle, you're not going to see this line because ABD, no, ABD. ABD is only this triangle, ABD. So you should see it without this line, ABD. So this is angle 1. This whole thing is angle 1. Is equal to, when you take up the other triangle, what's that? ABC. ABC, it's this one. ABC is this one. When you take up this triangle, don't see this line segment which runs through it. Don't see this. ABC is only this one, ABC. So this is angle 2 completely. Angle 2. Angle 1 is equal to angle 2. And then AB is the common side. If from the name you can make out, from the name of the triangles, from the names of the triangles, you can make ABD, ABC, AB, AB. So AB is a common side. ABD, ABC. See, we have to prove that these two triangles are congruent to each other. Here the order, I have written ABD and ABC. That's fine. Here you can write, you just have to name the triangles. The order is not important here. When you say that they are congruent, then the order is important. So mention the equalities, and now you know how to name the triangles in the correct order. They're congruent, and once they're congruent, CLBD is equal to AC, CP, CTC. Angle ABD is equal to BAC. How do we make out that? ABD and BAC, you can see it from here. They've asked you if ABD is equal to BAC, this one. So just check ABD. See here, ABD. 1 minute. ABD. Angle ABD is congruent to angle BAC. CPCTC. The other angles that are equal are angle, if you say angle BAD is congruent to angle ABC. Just play with the vertices. Whatever order you take in the first case, take the same order in the second case. If you say angle BAD, it's congruent to angle ABC. This is how the triangles are named when they are congruent. So supposing you're talking about angle DBA, if you're talking about angle DBA of the first triangle, angle DBA of the first triangle. If you say angle DBA of the first triangle, it is CAB of the second, because DBA, so it will be CAB. It will be angle CAB of the second triangle, angle CAB. These two are the congruent angles. Equal angles. So ABD, BAC. So you see here ABD, angle ABD is equal to angle BAC, CPCTC. So, but please draw the triangle separately so that you understand better. Like this is one triangle. This is the other triangle. Already given these two angles are equal, given. Then this side is equal to this side given, and this is the common side. So when you take this triangle, it's given that this angle is equal to an angle in the other triangle. This side is equal to another side in the second triangle, and this is the common side. Draw this triangle separately to understand that. Now, as I'm drawing, please understand. So this is A. You must take some effort, children. ABD. This is ABD. AD. Then this BC, and this is angle 1. And this is again the triangle ABC. That's what we have to take up, ABD, ABC. Wherein AB is a common side. AD is equal to BC. AD is equal to BC. And this angle 1 is equal. All this is given. Nothing we're doing. See, no effort. Effort is only to draw. To find equalities, no effort. Everything is given. See, AD is. First, you should take up the triangle separately. It's mentioned ABD and BAC. Draw the triangle separately. And then mark off whatever equalities are given. AD is equal to BC. Mark it. These two angles are equal. So angle 1 is equal to angle 2. And then AB is a common side. That is not given, but you can make out from the triangles the names of the triangles. ABD, ABC, AB, common side. Any questions, children?
No, ma'am.
ma'am.
Okay. Yeah. So AD and BC are equal perpendiculars to a line segment AB. AD and BC. So the line segment is AB. This is the line segment AB. Okay, they marked A here and B here. This is the line segment AB. AD and BC. AD and BC. So this is AD. This is AD. And BC goes in the opposite direction. BC, like this BC. AD and BC. They're equal perpendiculars. They're perpendiculars meaning they make 90 degrees. They're equal perpendiculars. That means they're equal. These were equal. This is the line segment AB. This is the line segment AB. B. This is B. And this is A. Line segment AB. AD, BC. AD, AD, BC. BC, AD. They are equal. AD and BC are equal. Equal perpendiculars. They are perpendicular to AB. They're equal perpendiculars to the line segment AB. So that means 90 degrees. AD is perpendicular to AB. So 90. Similarly, BC or CB is perpendicular to AB. See, this is CB. This is CB. It's perpendicular to AB. That means 90 degrees here. They're equal perpendicular. So I've marked equal. Show that CD. So CD is this line segment. CD, this line segment. Show that CD bisects AB. So CD cuts AB into two equal pieces. This is O. We must show that CD bisects, that is, cuts AB into two equal pieces. CD is like the knife here. CD bisects, CD cuts. CD is not bisected. CD is bisecting something else. CD is not bisected. CD bisects AB. That means AB is cut into two equal halves by CD. CD is the knife that cuts AB into two equal pieces. So what should we prove, children? What should we prove? What should we prove?
CD bisects AB, ma'am.
AB,
That
ma'am.
means, yeah, that means what? What should we show? CD bisects AB. That means what equality have we to prove?
And that it divides AO is equal to diagram OB. into two triangles.
No, my question is like if CD bisects AB, what is that? Which line segment should be equal to which line segment? Which are the two line segments that should be equal to show that CD bisects AB?
OD and OC,
OA
ma'am.
and O.
OB and
OD and OC, ma'am.
And OA.
OD and OC means CD is bisected.
OB and OA.
Sorry, ma'am. OA and OB, ma'am.
Yeah, OA and OB. Somebody said this earlier also. OA and OB. If you prove OA is equal to OB, that means AB is bisected by CD. If you prove that OD is equal to OC, maybe that is true, but that they have not asked you to prove. Maybe it is true, but you have to prove CD cuts AB into two equal halves. So AB is cut into two equal halves, which means you should prove that OA is equal to OB. OA is equal to OB. OA is of one triangle, OB is of the other triangle, right? We have to prove that OA is equal to OB. This result can be achieved by proving that the two triangles are congruent. Once you prove that they are congruent, why should we prove they are congruent? Because to get a result like OA is equal to OB, OA is the side of one triangle, OB is the side of the other triangle. And when can the two sides of two different triangles be equal? When the triangles are congruent. So we'll prove that the triangles are congruent to each other, then the result will follow by CP/CTC. OA is equal to OB. So that proves that CD bisects AB. Children, I told you, you must also take some efforts. Please don't sit there thinking that, no, I don't understand. You have to make yourself more clear, please. I'm trying my best. You too must have been focusing all the while. That's all. Just prove that the two triangles are congruent and so you can see here, we've listed the pairs of equalities. So here you can see, you will later see that AAS is also a valid congruence criterion. You can also prove this using ASA. You can prove this using, depending on what you write. What rule you use depends on what you have written. Now here it is AAS. You can also do ASA. Here it is AAS because we have mentioned about two angles, angle 1 and angle 3. Angle 1 and angle 3. Here about angle 2 and angle 4. But we have mentioned about the sides BC and AD. BC and AD are not included by these two angles. AD is not, okay, which is the side included by angle 1 and 3? Which is the side included by angle 1 and angle 3?
OA, ma'am.
OA. Which is the side included by angle 2 and angle 4?
OB, ma'am.
OB. Angle 1 and 3, angle 1 and angle 3 include the side or contain the side OA. Angle 2 and angle 4 include the side OB. But we have not mentioned about OA and OB. That's what we have to prove. We have mentioned some other sides. So clearly we have not mentioned anything about the included sides. We have mentioned about two equalities of angles. So AA and some other side S. So it's not ASA. AAS rule. Two angles and some other side. By AAS congruence criterion, the two triangles are congruent to each other. Write the order correctly. When you use AAS, it's very easy. Just match the angles. Angle 1 and 2 are equal, no? So O, when you say O in the first triangle, it is O in the second triangle. And then if you write A in the first triangle, if you say A, you must say B in the second triangle because angle 3 is equal to angle 4. So if you say A, that is angle 3, you must say angle 4, that is B. That is B. Then the third vertex, OAD, OBC. So you can see there, OA is equal to OB, CP, CTC. OA is equal to OB, CP, CTC. So this proves, so you have proved that OA is equal to OB. That means what does this result mean? OA is equal to OB. That means O is the midpoint of AB. This means O is the midpoint of AB. That is CD bisects AB. CD cuts AB into two equal halves at O. Is that fine, children?
Yes, ma'am.
All right, children. So that's it for today's session. If you have not completed, I've already shared the videos with you. If you have not finished these proofs with the help of the videos, now you get your chance to, complete it. You've taken screenshots. Now it's more easier for you. Please complete the proofs by the next class. If you have any questions, please stay back, children. Else you may leave the call. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night.